When Joshua was visiting our lab, we had two, among many other things, we had two interesting points that we talked about that I thought Chris could talk about as well. Which one was about error correcting codes. So maybe we can start with that, and then the other one had to do with protocognitive capacities at the bottom of the scale, particles and things like that. So I don't know. Maybe we start with the error correcting codes. You guys want to talk about error correction and how you see it? Maybe Joshua, do you want to go first and just summarize what you were saying?
Yes. So very briefly put, the reason why there's something rather than nothing is probably because the universe is not impossible. So if you're in base reality, nothing precedes the universe to make it not happen. It's going to have an existing in the non-existing branch. In the non-existing branch, you don't get observers that complain. So you basically have existence for free. Now we need to figure out why some things are happening in the existing branch and others are not happening. And the easiest answer to that is that simply everything is happening because there's nothing preceding the universe to select operators. So basically, universe is a superposition of all operators, which means it's a multi-way system. And you yourself being computed by it don't know which path you are. So the universe for you is going to have the appearance of being indeterministic, which means that if you zoom in at the lowest level near the vacuum, you'll see lots of random fluctuations that usually don't amount to anything. In order to build structure, one part of the universe needs to do what another part of the universe is doing. So sometimes you get these circumstances where you have a pattern that remains stable, statistically stable. You will not be able to figure out whether you are in the path where the universe is going to, where the photon is going to the right or left slot, but you know what a million photons are going to look like. In the same way, you don't know which operator is going to happen next, but you know what the superposition of operators is going to look like when you have enough of them and in a certain starting state. And sometimes basically you get a situation where the universe is going to perform error correction. A good metaphor, I think, is you sit in a bathtub, you move your hand, you see on the surface of the bathtub lots of patterns emerging, lots of waves, most of which are just dissipating, not amounting to anything. But sometimes you get a particle, which means a vortex. And the vortex has this property that it's basically circular, so it's shoving the information around in the same volume of space and doesn't dissipate until friction makes it disappear or until it bumps into something. It's not that the water in the bathtub wants to produce those vortices more than other things, it's just what's left over. And I suspect that the same thing is true for all the particles, that basically they are error correcting codes. And the simplest one are control systems that act in the present on the present state or just the immediate state after that. And slightly more complex control systems have a certain degree of elasticity, like molecules, you can squish them and they bounce back into shape. And cells are controllers for future states. They're agents. They basically make models of future paths so you can remain stable over much more complicated circumstances. And in this way, you could say that life itself is an error correcting code that allows to keep particle configurations stable that otherwise wouldn't, and control regions of the universe that wouldn't. And of course, it doesn't stop at the level of cells, but also there are systems above the levels of cells, like organisms, societies, and so on, where you find the replication of those control principles.
What? That all sounds good to me.
Good. Next.
That's it.
Thank you for being so patient.
Wow.
So the conclusion from that train of thought is that one way of thinking about mental representations is to look at them from the perspective of error correction, to look at them as quasi-particles. Right? The difference between heat and sound is not that one is not bouncing molecules and the other is not. They both are, but sound is information preserving. It's even quantized. If you look at phonons, it's a quasi-particle that is emergent over the activity of the molecules. It's what's left over after you dissipate the heat in some sense. In the same way, if our brain is, we can see it maybe as an ether, where the individual neurons are nodes that are passing on signals from neighboring nodes in the topology. And then if that thing is stable, information preserving, so you can compute with it, it's basically representations, activation waves are something like quasi-particles moving through this thing.
Yeah. So, yeah, are you familiar with Friston's work on free energy?
Mm-hmm.
Yeah. Okay. So, I mean, I guess I interpret I see the free energy principle in its simplest form as saying something much along these lines, that any system that persists, that remains stable, has to do something or other to keep its boundary intact. So it has to effectively be autopoietic. It has to maintain some level of structure.
Yes, but not its
So
boundary in
whatever
space,
the system
boundary in
looks
time.
like, pardon me?
It needs to keep its boundary in time intact, not in space, right? Needs to write itself into the future, but it can be something that is actively colonizing as long as nothing invades it.
Yeah, it has to write some bounded set of values of some bounded set of degrees of freedom into the
Yes.
future.
But for instance, life doesn't need to keep its boundary intact in the sense that it needs to be worried about being invaded by nothingness. It's because it can just itself invade chaos, but it needs to keep its boundary in time intact. Basically, its frontier by which it writes itself into the future needs to preserve it.
Okay, yeah. By boundary, I mean state space boundary.
Yes.
So yeah, put everything in a Hilbert space or something.
Mhm.
That's the boundary that's of interest.
Yeah.
In the free energy principle. So one, I think, can translate what you just said into free energy principle terms without too much trouble. It's certainly consistent with what the free energy principle says. Although the FEP community doesn't seem to talk about error correcting codes very much. They talk about persistent structure instead. But since they fundamentally think of systems as informational structures, maintaining a consistent structure, if you're an informational structure, just is being an error correcting code.
Mm-hmm.
So I think that hangs together quite nicely. I guess another reflection, I think, off of what you just said is the Zurich's quantum Darwinist picture, which you probably are familiar with also, in which state components of some system are being selected by its environment for stability. And again, it's a very boundary preservation sort of idea. If you fix the boundary between the system and its environment, then you fix the interaction at that boundary. And given an interaction for the whole system. And then the stability of that interaction is effectively has to be preserved by the system and its environment working together. And in that case, the eigenvalues of the interaction are essentially being preserved by an error correcting code. The code space being the internal dynamics of both the system and its environment. And I guess the third kind of perspective on that is sort of the more general perspective of error correcting codes that's operable in things like ADS CFT, where the state of some volume is coupled to the state of its surface. So again, a question of although there in that community they don't talk explicitly about observation, they take that for granted. So there is something or other going on in the surface that's describable by some theory.
Oh, I suspect that the ADS CFT conformance is a bit of a red herring. I think that the universe fundamentally is automata, right? So it is not a volume or not a surface because it's not geometry. Geometry is only what happens when you squint at automata at scale.
Yeah. No,
And so,
okay.
of course, you need to have some kind of conformance like this if you have a field description of the universe and the graph description, and you need to map between them. Right, space-time is basically a set of locations that we can make out and the trajectories that information can take between them. And that puts some constraints on what spaces you can observe if they give rise to systems like you within them.
Yeah, terrific. Yeah, I completely agree about space-time being emergent. In fact, Mike and I have been talking for some time about
theory is, I don't really know what it exactly describes. If you look at the LLM, that seems to be a radically Fristonian machine in that it's trying to minimize the prediction error. And you could say that it's there is free energy minimization going on at some level. I suspect that for organisms, it's happening in the limit, like for all life on Earth or something like that. But individual organisms look for more concrete things because they are occupying only a small region in the space of behaviors, right? In some sense, humanity is not an independent species. It's more an organ in the entire dance of the cell on Earth. And our particular role in this organ is just to burn the oil, apparently.
No, our role is to really provide walking apartment houses for bacteria.
Well, that's true for all large organisms. But I think we are the only organism that is able to basically collect this particular entropy, the accidentally fossilized biocarbon that was turned into trees before there were enough insects to take the trees apart. And so our role is to basically put it back into a circulation so Gaia can make new organisms. And I don't know whether Gaia already planned for us to wake up the rocks. I think if that happens, there is the next stage of evolution, right? It's going to be awesome because we are going to have substrates to run consciousness on that are magnitudes faster. Which leads me to this question what consciousness is. And I suspect that it's not a prediction error minimizer, but a coherence maximizer. It's basically an operator that is not working like the transformer does in the LLM, minimizing some prediction error, but it's a colonizing operator that takes suitable, trainable, but somewhat chaotic substrate and then imposes an administration on it that is locally coherent. So it acts in such a way as if it was a single agent.
Is there any operational difference between those two?
I suspect it is because we see that the LLM is becoming coherent in the limit. After you train the entire internet into it and use almost all of the compute on the planet, it's almost coherent. But it does lack the creativity right now to
yeah, I mean, you could say the same thing about people, right? Most of us are not coherent all the time.
Yeah, but that's also because I think humans are evolved to be domesticated. We are not the smart hominid, we are the programmable hominid. We can walk in lockstep. So basically a lot of humans, when they are confronted with the opportunity to be truthful or to be in synchronization with the environment, pick the latter. And you can see why that is evolutionarily beneficial under the conditions where their ancestors grew up. But I also think that there are a lot of humans which lack that limitation, and they are basically generally intelligent within the limitations of their substrate, which are severe. But if we put them onto a different substrate, there is nothing that they cannot do.
Be interesting to test.
Mm-hmm.
Never get it past the IRB.
See it.
I mean,
History tries to test it, but we can't replicate those experiments.